Hi there. So in this video with tables, I'm going to show you how to program the CL for the teacher dashboard. And in this example, we're going to use a table, but it's not actually going to be where the correctness check is going to be, because the table is going to show students what the rule is in disguise by telling them what the points are. Based on their input for X, it's going to give them an output for Y. And then they have to determine what the rule is and enter the equation into the box that's provided over here, the math input. So we can use any equation that we want in the background without students knowing it. We just have to be consistent as we use it. And I prefer to do most calculations in a graph and then hide the graph. It just seems really clean and neat for me, and I don't have to fuss around with the intricate things that can happen with CL. So I'll demonstrate a hidden graph here for you as well. As I was saying, the correctness check is just going to be for the math input. We don't have to correctness check the table. It should be correct because we're setting it up. So we're just going to say read only true on that table. And while we're at it, let's call this table 9 and input 9, and I'm going to insert a graph and call that graph 9. Now, because the graph is going to be hidden, I'm going to put it down at the bottom of the screen, and in the CL, I'm going to say read only true, and I'm also going to say hidden is true. So I want it to be hidden, and I want it to mark it correct no matter what. Now, in order for the graph to do any calculations, it needs to know what the student is inputting. The student's going to input in the first column of that table in the X values. So we want to pull that number list, that list of numbers that the student's inputting for X, and we want to call it something. So I'm going to call it X sub all because I'm pulling all of the X's all at once, the entire list of them. And we need wavy brackets around the word all because it's more than one character long. It's 3 characters, so it needs wavy brackets. And then we want to say, where are we pulling from? So we're pulling from the table, and it's table 9. And what are we pulling? We're going to pull the entire column worth of stuff, the column numeric values for column 1. So that's all of the X's are getting pulled from the table and going over to the graph. We're not saying what to do with them yet. We need to do that next, but they're now available for the graph to read. So now we're going to go into the graph component itself and say what we want to have happen here. Let's see, 1 second. Bring it in here. Okay, so in here we want to say that equation that we had. We're going to have a y sub 1 and an x sub 1. And before I do that, I should really say that x sub all is going to be made up of a list of items. So the square brackets indicate a list, and we're going to have x sub 1, x sub 2, x sub 3, x sub 4, and x sub 5. Those are the things that are going to come from the student's table. It's already getting pulled, it's going into here. So now we just want to do this a few more times. And we want to do an x sub 2 and an x sub 3. And I'm just having the y value, the y subscript correspond to the x subscript on here. We're going to get a 5 on here. And now the graph should be all set, but it's going to be hidden, so I'm just going to hide these just to kind of remind myself that nothing's going to show up on the graph. So it's going to do the calculation. The calculation is going to be stored as a y sub 1, a y sub 2, a y sub 3, so on and so forth. So if we go back here right now and we input something like 7, it looks like nothing's happening. But in the background, it's taking this as an x sub 1, the 7. It's doing the calculation, 7 times 2, subtract 5. And it's got in the hidden graph, it has the y sub 1 already calculated and stored. We just have to tell the column, or sorry, the table here to put that graph's number that's already been calculated into this cell right here. So we want to tell it to put content in. So cell content for cell 1, 2, row 1, column 2, is going to be the answer from the graph. So I like to just pull out those answers like this. It's going to be y sub 1, so I'm just calling it y1. This is not where I use the sub notation here. This is just pulling it back from the graph. And the number is going to be y sub 1. So why am I getting an error? Let's see. Graph 9, number y sub 1. Let's see what it says. Cannot find x sub 1. All right, so one thing that might be happening is that I need x sub all and element 1. That'll take care of the x sub 1 thing that's happening. This would be element 2. This will be element 3. This one's going to be element 4, and this one's going to be element 5 of the list. So that way we don't have to worry about x sub 1 and so on and so forth. Going back into here, that cleared that up. So we want to put that variable y1 is what I'm calling it. I want to put that variable in here. And if I just type y1, I want to show you what happens. Says y1, but we don't actually want it to say exactly what I just wrote, y1. We want it to take what the numerical value of y1 is. And so, but it's coming from another spot. So the way to do that is to put a $sign and then wavy brackets around the variable that you're using. And now if I pull it, it'll say undefined for now, but that's just because I don't have anything here. So let's say I put 4 in. I get 3. If I choose to put 10 in, I get 15, so on and so forth. So it's working now, and we want to do that for each of the rows. So I'm going to repeat this a few times. And make sure to change them in what they are called as well. Really name it anything, but it is helpful to name it something that you will be able to understand what it stands for. Cell content of 22, 32, 42, and 52 is going to be these different y values that are calculated in the graph. All right, so let's take a look at how that looks now. 1, 2, 3, 4, and 5. So the student can input whatever they want here, but whatever they input, it'll properly figure it out over here. And so they'll have to kind of use their skills to figure out what the equation is for this. And they're going to input the equation over here. Now I think I still have it. Oh, I don't have it on my paste. Y equals 2x minus 5 is the equation. So that's what we want the student to enter, and that's also what we want to have checked. So we need to go into the math input now and do a correctness check here. But we need to set up functions, like this is going to be one of our functions. So in here, let's use f, like f of x, a function. And instead of using simple function, because it has there's an equal sign in there. It's not just an expression. So instead of simple function, I'm going to use parse equation. That way we don't have to worry about that equal sign. This along with the difference function is going to take care of that. Difference function, and what are the variables? It's going to be an x and a y. All right, so that's like the answer key, and now we're going to set up a g function, and this is going to be not f. Let's get rid of that. This g function is going to be whatever the student types in. So the student is going to type in something in, where are we right now? Yeah, we're in the right box. So I'm going to say this, and then they should be typing in LaTeX. It's an entire equation. It's not a number. So the two functions that we want to see if they are the same are set up. And to see if they're the same, we're going to evaluate the f function at something for both x and y. We're going to evaluate the g function for something, both x and y, same something that we just evaluated f at, and see if they're the same. So we are ready for a check. We're going to do f.evaluate at, and because we have both an x and a y, we need two numbers in there. And you can pick whatever you want, but I just kind of stick with numbers in order, unless there's a reason not to. But I'm just doing a few checks at a few different spots. And you can see that I still have errors right now, and that's because I'm doing a check. So when you're doing a check, it's this, and this, and this, and I don't have the and in there yet. So let's get those in. So check is all set, and now we can put the check variable in for the correctness check. Going in here, we can put whatever we want here. And over here, hopefully the student is going to enter in 2x minus 5. And if they do, it'll mark it correct. And it doesn't have to be in this order. So like I could just put the positive 5 over here, 5 plus this, and it'll still recognize it as being a correct equation for this function. And it'll mark it correct. All right, that's it.